Welcome to Intelligence Gateway. What is the role of artificial intelligence, AI, in edge computing? The role of artificial intelligence, AI, in edge computing is to enable intelligent decision-making and real-time data processing at the edge of the network, closer to where data is generated, rather than sending all data to a centralized cloud for processing. AI algorithms can be deployed on edge devices to analyze and make predictions on data in real time, leading to faster response times and reduced network latency. What is the role of machine learning, ML, in edge computing? The role of machine learning, ML, in edge computing is to enable intelligent decision-making and real-time data analysis at the edge of the network, where the data is generated, without the need for centralized processing or cloud computing. ML algorithms can be trained and deployed on edge devices such as sensors, cameras, and other Internet of Things (IoT) devices, allowing them to analyze data and make predictions locally, without relying on a remote server. This can reduce latency, improve response times, and enhance the overall performance of edge computing systems. What is the role of blockchain technology in edge computing? Blockchain technology can enhance security, privacy, and trust in edge computing by enabling decentralized, immutable, and auditable storage and sharing of data and computation results among edge devices and parties. What is the role of fog computing in edge computing? The role of fog computing in edge computing is to provide a layer of intermediary computing resources between the edge devices and the cloud, enabling faster and more efficient processing of data at the edge. This helps to alleviate issues related to latency, bandwidth, and security that can arise when relying solely on cloud computing for edge devices. What is the role of serverless computing in edge computing? The role of serverless computing in edge computing is to provide a way to execute code on the edge device without the need for a dedicated server or infrastructure. This enables developers to build and deploy applications that can run closer to the end users, reducing latency and improving performance. What is the role of containerization in edge computing? The role of containerization in edge computing is to enable the deployment of applications and services in a lightweight and portable manner, allowing them to run seamlessly across different edge devices and environments. Containers provide an isolated and self-contained runtime environment for applications, making it easier to manage and scale them at the edge. Additionally, containerization helps to reduce the dependencies and conflicts between different software components, which can simplify the development and deployment of edge applications. What are the different types of edge data storage solutions? The different types of edge data storage solutions include 1. Local storage on edge devices, storing data on the edge devices themselves, such as laptops, smartphones, and sensors. 2. Edge gateways, devices that aggregate data from edge devices and store it locally before transmitting it to a cloud or central data center. 3. Edge servers, servers located at the edge of the network that stores and process data locally, reducing the need to transmit data to a central location. 4. Fog computing, a decentralized computing infrastructure that extends the cloud computing paradigm to the edge of the network, enabling data processing and storage closer to the source of data generation. What are the different types of edge data processing solutions? The different types of edge data processing solutions include edge computing platforms. These are software platforms that enable the deployment, management, and scaling of applications on edge devices. Edge gateways, these are hardware devices that connect edge devices to the cloud and provide local processing and storage capabilities. Edge analytics software, this type of software is designed to run analytics and machine learning models on data collected at the edge, enabling real-time decision-making. Edge storage solutions, these are local storage solutions that allow for data to be stored and processed at the edge, reducing the need for data transfer to the cloud. Edge security solutions, these are security solutions designed to protect edge devices and data from cyber threats, ensuring the integrity and privacy of the data. What are the different types of edge data analysis solutions? The different types of edge data analysis solutions include edge analytics platforms, edge devices with embedded analytics capabilities, edge gateways, and fog computing. What are the different types of edge data visualization solutions? The different types of edge data visualization solutions include 1. Embedded analytics. These are data visualization tools that are integrated into existing software applications and provide users with real-time data insights. 2. Edge computing platforms. These are cloud-based platforms that can collect, process, and analyze data from IoT devices at the edge of the network and provide real-time visualization of the data. 3. Dashboarding tools. These tools provide real-time visualizations of key performance indicators, KPIs, and other data metrics, allowing users to monitor the performance of their systems. 4. Augmented reality, AR, visualization. AR technology can be used to provide real-time data visualizations overlaid on the physical environment, allowing users to interact with and explore data in new ways. 5. Mobile data visualization. Mobile apps can provide real-time data visualization and analytics, allowing users to monitor and analyze data on the go. What are the key features of edge computing? Edge computing is a distributed computing model that brings computing resources closer to the edge of the network, where data is being generated, processed, and consumed. The key features of edge computing include 1. Low latency. Edge computing reduces the distance data needs to travel, resulting in faster response times and reduced latency. 2. Increased efficiency. Edge computing reduces the amount of data that needs to be transferred over the network, reducing network congestion and increasing efficiency. 3. Improved security. By processing data locally, edge computing can enhance security and privacy by reducing the need to transmit sensitive data across the network. 4. Scalability. Edge computing allows for the distribution of computing resources, enabling applications to scale quickly and efficiently. 5. Real-time data processing. Edge computing enables the processing of data in real time, which is essential for applications that require immediate processing and response times. How does edge computing differ from cloud computing? Edge computing is a distributed computing paradigm that brings computation and data storage closer to the location where it is needed, such as at the edge of the network, near IoT devices or sensors. On the other hand, cloud computing is a centralized computing model that relies on remote servers to deliver computing resources, such as storage, processing power, and applications, over the Internet. In short, the main difference between edge computing and cloud computing is the location where the computing is performed. Edge computing happens locally, closer to the source of data and the end users, while cloud computing happens remotely, relying on centralized data centers. What is the role of gateways in edge computing? The role of gateways in edge computing is to act as a bridge between devices at the edge of a network and the cloud. They enable local data processing, analysis, and storage, while also providing a secure and reliable connection to the cloud for data transfer and remote management. In essence, gateways help to decentralize computing resources, reducing latency and improving overall system performance. What is the role of edge servers in edge computing? The role of edge servers in edge computing is to bring computational resources and storage closer to the end users and IoT devices, reducing latency and improving overall performance. Edge servers act as local data centers that can process and store data generated by nearby devices and applications, without the need for transmitting data to centralized cloud servers. This allows for faster response times and greater efficiency, making edge computing an attractive solution for various industries, including healthcare, logistics, and manufacturing. What is the role of edge analytics in edge computing? The role of edge analytics in edge computing is to process data close to its source or point of generation, allowing for faster analysis and decision-making without the need for data to be transmitted to a central location. This helps to reduce network latency, bandwidth usage, and dependence on cloud services, making edge computing more efficient and scalable for various applications. What is the role of big data analytics in edge computing? The role of big data analytics in edge computing is to enable data processing, analysis, and decision-making at the edge of the network, closer to the source of the data. This allows for faster response times, reduced latency, improved bandwidth efficiency, and better security and privacy. By leveraging big data analytics at the edge, organizations can gain insights in real time and make informed decisions based on the data generated by their IoT devices and sensors. What is the role of cybersecurity in edge computing? The role of cybersecurity in edge computing is to ensure the security, confidentiality, integrity, and availability of data and applications that are processed and stored at the edge of the network. This includes implementing measures such as authentication, encryption, access control, and intrusion detection and prevention to protect against cyber threats that may compromise edge devices, networks, and data. What are the security challenges of edge computing? Some of the security challenges of edge computing include 1. Increased attack surface. The proliferation of edge devices and the decentralization of computing resources can increase the attack surface for cybercriminals, making it more difficult to secure the network. 2. Lack of standardization. There is a lack of standardization in edge computing, which can make it difficult to secure and manage edge devices and networks. 3. Limited resources. Many edge devices have limited resources, such as processing power and memory, which can make it challenging to implement security measures. 4. Connectivity issues. Edge devices may have limited connectivity to the internet, which can make it difficult to receive updates and patches in a timely manner. 5. Data privacy. Edge computing often involves processing sensitive data at the edge of the network, which can increase the risk of data breaches and privacy violations. 6. Human error. The decentralized nature of edge computing can make it more difficult to manage security policies and enforce best practices, increasing the risk of human error. Thanks for watching. For more information, like, comment, and subscribe our channel.